Hi, my name is Constance Gorman, and today we're going to expand upon what you've already learned about systems of equations. So I'd like to share a problem with you. All right, so the Drama Club is putting on a production of the Cher Wizard of Oz, the production of the Wizard of Oz. Let me move this down, and is charging $5 for students and $7 for adults. On opening night, they made $626 from 100 audience members. How many of each type of ticket did they sell? Now, most students and adults, believe it or not, are really skittish about word problems. So sometimes it's in your best effort to read it twice. The first time around, usually you only really get maybe 20% of what they're talking about. So second time around, the data starts making sense. Sometimes some students have to read it 3 times. So give yourself a moment to read it again silently yourself. Okay, so now if you're still stumped, the very first thing you should think about is, what have we been studying? System of equations. So you're used to solving for X and Y, and we always come up with 2 equations, right? So that should give you a hint. So you should look at this and say, oh, okay, so what would be my X value and what would be my Y value? So you may have to think about this for a minute. So let me annotate here. Okay, so we know in a system of equations, we have an X and Y value. So there are 2 variables. In this problem, what are the variables? They want to know how many of each type of ticket did they sell. So at this point, we know that we don't know how many student tickets are sold and we don't know how many adult tickets are sold. So let's just say X will represent student tickets and Y will represent adult tickets. Now, some students may say, well, what if I choose X to be the adult ticket? That's okay. You'll still get the right answer. Okay. So now, if you recall that whenever, let me stop annotating here. So whenever we had a system of equation, we had 2 equations that to come up with, to create. When you were first learning about system of equations, I gave you the equations. Now to come up with the equations is a little more difficult for most students. So let's start off with the easy one. Well, we know we sold 100 tickets because they said there were 100 audience members. And we know we have adult tickets and students tickets. So that makes sense that we would say the X number of student tickets plus the Y number of student tickets should equal 100. Let me make that a little bigger. There's our first equation. That has to make sense. Okay, so now the second equation is usually where students kind of struggle. So what do we know about the problem? Well, they took in $626. And we know it was $5 for student tickets and $7 for adult tickets. So it makes sense that the total amount they took in would be $5 times the number of student tickets, which is X, plus $7 times the number of adult tickets they took in, and that should equal $626. Let me make that bigger. Now, we all have had a lot of experience with systems of equations. So we algebraically, excuse me, I'm getting ready to sneeze. Excuse me. anyway, we've had a lot of practice in solving for X and Y, so you could solve for it algebraically. Now, there is another method for solving. Some of you aren't too keen on algebra, and there is a way of solving by doing it mathematically. Okay, so we could create a graph of each equation and find the intersection point. Now, the very first thing we need to do is, let me see if I can make this smaller, is we have to come up with the equation of each of these, in the y equals mx plus b format. Okay, so right now we're working with x plus y equals 100. So let's isolate y. And you can do that algebraically. And the equation would be y equals 100 minus x. Okay, so that's the first equation reformatted. So now let's reformat the second equation. And it's just simple algebra to get y by itself. So we have y equals, and you can do this on your own as well. And I got 626 minus 5x, and that's all divided by 7. Okay, so the advantage of having the equations into the y equals mx plus b format is that we're able to come up with the y-intercept and at times the x-intercept. So in this case, in the first equation, remember the constant is always the y-intercept. So in this case, it's 100. And in the second equation, the y-intercept is going to be 626 divided by 7. So remember, each of these terms are divided by 7. So 100 is easy to plot on our graph. 626 may not be so easy, okay? So I went ahead and graphed each of these equations. Let me erase what I have drawn on here so it doesn't interfere with us. Move this up here. Okay, so the line in yellow is our easy equation, y equals 100 minus x. And I graphed that because that one was easy. The y-intercept is 100. And the x-intercept, remember, you make y 0, so x would have to be 100. So that was pretty easy to graph. The second one, not so easy, considering what I have is increments on this y-axis. So this is the y-axis and this is the x-axis. And you have to be careful according to how much graph you have and what you make the value of each box. So given the graph that I have, I could only really make each box 10 or maybe even 5, but it would go off the chart. Now I've used every part of this graph. So like I said, graphing this point was easy and this point was easy because they're both 100, the x-intercept and the y-intercept. But in this case, this point is going to be 89 something. Let's see, I figured it out on my calculator. Let's see if it's still there. Yeah, 89.42. So that's going to be tough. 89.42 would be the y-intercept. And the x-intercept is, so this is going to be the y-intercept, and mathematically I figured out what the x-intercept would be, 125.2. That's tough to graph, isn't it? But where those lines intersect is going to be the solution for the system of equations, and I circled it with right here. So the intersection point is somewhere in here, but do you realize that graphing the system of equations is not good unless you can fine tune each block to have maybe each one represent one, and you would need 100 blocks plus, to be able to even get close. So truthfully, this problem is not solved easily by graphing because the numbers are just too large and they are decimal numbers. So it's better to solve this one algebraically, okay? So you have a choice. You can graph it or solve it algebraically, but if you find that you're having difficulty with the numbers, it's better just to do it algebraically. So I hope this helps. At least you have two alternatives. All right, so let's stop the sharing. Whoop, wait a minute. Got to move this out of the way. And I hope this helped you to determine that, maybe decide which way you would like to solve a system of equations. either graphically or just using old-fashioned algebra. Okay, bye-bye.